All right, we got our table started. Ready to roll? All right, like we said, we made these last class, and we didn't go any further with it. We listed SSS, SAS, ASA, AAS, and HL as the 5 ways that we could improve. Now, we did say that there were a couple more, but we can lump these other ones into these 3 categories, so there's no need to repeat them. These four right here are generic. Okay, they work with any triangle. This one is specific only to one kind of triangle. Right. Right triangle. Why? How do you know? Without me giving you that, what does that H stand for? And the only kind of triangle that has a hypotenuse is a right triangle. So we'll talk about what that. Now, what does it mean for 2 triangles to be congruent? Start there. When I tell you 2 triangles or 2 figures are congruent, what does that mean?
Same size, same shape.
Same size, same shape. Okay? So same size, same shape, well, same shape, if we're dealing with triangles, they're both going to be triangles. A triangle and a rectangle cannot be congruent, or I should say a triangle and a quadrilateral. Okay? Now, S, S, S.
Same.
Almost.
Side.
Side. So this is side. So what it says that if 2 triangles, if 3 pairs of sides are congruent in 2 triangles, if there are 3 pairs of corresponding sides that are congruent, and the 2 triangles are congruent. In 2 triangles, if 3 pairs of corresponding sides are congruent, then the triangles are congruent. This does not say that we have what kind of triangle. This does not mean that we have equilateral triangles. Okay? This could be 2 scalene triangles. This does not mean that the 3 sides in one triangle are congruent. It means that the corresponding pairs, the 3 corresponding pairs of sides are congruent. Now, I drew this very basic. I drew it very simple so that they match up really easy. Okay? 1 pair, 2 pair, 3 pair. Right? So if we have 3 pairs of corresponding sides that are congruent between 2 triangles, then those triangles are congruent. What's the one thing that is not mentioned in this one? Angles. Okay, angles. If the sides are all congruent, the angles then will be congruent. Okay. Now, what does SAS stand for? Side, angle, side. Where's the angle? Between. Now, there's a special thing that we're going to say, not just between. We're going to say included. Okay? So, in 2 triangles, and these are all going to start off pretty much the same way. In 2 triangles, if 2 pairs of congruent, or 2 pairs of corresponding sides are congruent, if 2 pairs of corresponding sides are congruent, and the included angles are congruent, then what can we say? What are they? then the triangles are congruent. Okay. So included is the same thing as between when we're doing this. So we're looking at two pairs of corresponding sides and the included angle. What's another way we can think of that included angle? How is that angle created? The angle that is congruent is created by the congruent sides. Okay. You monkeys down. Maybe we won't play the monkey. Okay. How about this one? So we went from SAS to ASA.
That's just go through.
Nice try. Or it should be ASD, after school detention.
Angle side.
What is it? Angle side angle. Almost the opposite of side angle side. It is angle side angle. So the only thing that we have to do is where this one said side, replace it with angle. And where it said angle, replace it with side. Okay? So now, where is the side in reference to our angles? Included. Is the side included between the angles? So if we write it almost just like this, so in two triangles, if two pairs of corresponding, now this time instead of sides, we're looking at corresponding angles. I'm going to shorthand this because this box is a little small. Two pairs of corresponding angles are congruent, and the included side, or the included side is congruent. Then what happens?
And the triangles are congruent.
Then the triangles are congruent. Okay, all of these are starting the same way and they're ending the same way. We're starting with parts that we're looking at in two triangles and ending up with those two triangles being congruent. Right? So we went side, 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 angle, side, angle. Now, what is the AAS? Angle, side. Where's that side?
The other side.
What do you mean?
Not included.
Not included. Okay? So instead of angle, side, angle, where the side is included, the side now is not between the angles, so it is not included.
But Mr. Teacher, like angle side is also angle side angle. Because three angles equals to 180.
True. Three angles do add up to be 180.
So the three angles are equals. Two angles are equals, three angles are equal.
Only congruent.
Yeah.
Okay. I can have a triangle of this size. With three pairs of congruent angles. That does not mean that these triangles are congruent.
But there's still another side.
Sure there is. But that relationship has to be these, and these are not the same. Okay? These are not the same. We will get some, you will see this pictorially, visually, in a little bit, but these are not the same. Okay? And don't mix any of these up with this. This is similarity, we will talk about that later. Easiest way to talk about similarity is with a zoom feature. You take your picture, you take a picture of your camera, you zoom in, all of the ratios stay the same. Meaning when you zoom in with your face, you go like this side to side, it doesn't stretch your face out. Okay? It proportionally zooms in. Same way, if you go like this, it doesn't pinch your head and you keep your body the same. Okay? All the angles are going to be the same. That's similar. not what we're dealing with here. Okay? Very close, but not the same. So back to this, angle, angle, side. Start off the same way, in two triangles. If two pairs of corresponding angles are congruent, and this time, instead of the included, we're looking at the what?
Not included.
The not included. So two pairs of corresponding angles are congruent, and the non-included sides are, I should say, the corresponding non-included sides. What'd you say?
Mr. President.
Okay. What do you call it? Two triangles, if two pairs of corresponding angles are congruent and the corresponding non-included sides are congruent, then we have the same result. Our triangles are congruent. And it is very important, and the piece that is different is that the corresponding non-included. Because when we have two triangles, how many sides are not included between these two angles?
Two.
Two. So if I have a situation like this, are these two triangles congruent? No. Even though we have two pairs of congruent angles and one pair of sides, that is not included in those angles. The orientation is different than this. They have to be corresponding. That's the piece. Okay? That's the tricky part.
I can't read the corresponding one.
Okay, so in two triangles, sorry, I gotta squeeze it. Two triangles, if two pairs of corresponding angles are congruent and the corresponding non-included sides are congruent, then the triangles are congruent. Okay? The whole thing here is corresponding parts. Yes.
So what do you mean by non-included sides?
Well, this is what we're going to get here. Where is the side in reference to my angle?
Is that this, where it's in the middle?
Where is my side in reference to the no.
Okay.
Okay. That's what you get for the chips. Sure. All right. Now, those are the four generic ones that work with any triangle. And when I say any triangle, these work whether we are dealing with, doesn't matter. Scalene, isosceles, equilateral, triangular, acute, obtuse, or right triangles. This one, though, like you said, only pertains to right triangles. You cannot use HL when you are dealing with an obtuse triangle. You cannot use HL when you're dealing with acute triangles. Okay? Now, so this one's going to start off slightly different. Okay? This, well, I'll hold that thought for a second, see if you can pick up what I was going to say. All right? So this one's going to start off slightly different. Now, instead of just in two triangles, we're going to be in two right triangles. In two right triangles. Don't hurt yourself. In two right triangles, what are congruent?
Two sides.
Which sides?
The hypotenuse?
The hypotenuse, yes. All right. In two right triangles, if the hypotenuses and what?
And the bottom side.
Bottom, does it have to be bottom?
Base.
Width,
Base.
length,
Which leg?
Base.
latitude.
Very important word that we've used all through here.
Side,
Corresponding.
corresponding.
Corresponding legs, thank you. Okay, so in two right triangles, if the hypotenuse and a pair of corresponding legs are congruent, then the two triangles are congruent. Good?
Right, on the hypotenuse and then side. Wait, L stands for like.
Yes. Okay, that's same. Okay. Which one did I tell you that was not existent in geometry? When you all laugh and giggle with that.
That's ASS.
Yes, no ASS. We don't like to say bad words in geometry. What's this one?
Oh.
This is technically
Same thing.
angled side side. So this is our ASS. We just don't say bad words in geometry. So we call it HS. Bad language. Can't say bad language. Okay. These are what we're going to build on. These are things that we're not going to get away from for a while. These are the building blocks that we're going to take and we're going to go. We are going to go both ways. We are going to see if two triangles are congruent because of this, or we are going to use this to get information from our triangle. Okay, so we're going to use a two-way street here. All right. So in other words, we're going to take a look at some examples of triangles, and we're going to determine whether they are congruent. Right? So that's one way we're going to. Then we're going to look at some triangles, and we're going to say, okay, I know that they're congruent using one of these. What other information can I get? Right? And we're going to do all these things. Now, we're going to start very simple, and then we're going to work our way. All right, you ready? Ready, boy? Sure. I want you to hurt yourself. I want you to think too hard. All right. Like I said, let's start simple. Quietly, in your brain. Some of you guys got an issue with that. State if the two triangles are congruent. If they are, state how you know. Well, before you get into this, what are some ways that we can state how we know? Again, keep in mind, mathematicians are somewhat lazy. We're not going to write huge dissertations. So this is not a 5-page essay about how we know. Okay, we're going to use either SSS, ASA, AAS, HL, or which one is this? AAS. Okay, so look at each one of these diagrams. Try to determine, if any, which of those 5 that we can use.
How do you know if that's the right triangle? What does it say?
That's a yes. Yes. No, that's wrong.
Oh, no, it looks like.
No, but they
Sorry,
they share
first
it.
one.
Yeah, they don't get that.
First one is H.
It's the one that's they don't.
I think
No, I think
two sides have to be congruent. Two corresponding.
Okay.
Yeah, what's it say?
Let's see.
HL.
First one didn't come.
Yes.
It's not congruent, why?
It's not,
It's not.
it's not coming.
You kidding?
Yeah.
What do you think?
the point is, SAS, because you know that,
No.
because the line they share in the middle must be the same. So there's angle, side, side.
Yeah.
Oh, there's angle side side.
It's not,
See, it's HL.
Oh, there's HL.
there's no right
There's no
angle.
right
So we got a problem. So yes, we brought up a very good point. Something that we didn't say. These two triangles, what's so special about these two triangles? What do they do?
They share.
Well, we don't know.
They share a lot of,
It's yours.
They share a side. What happens when you have two triangles share a side? Don't get always confused with that. Everybody here, gentlemen, I want you to listen. Something was brought up. We said when two triangles share a side, that's a corresponding side and it's congruent. That's half right. Okay? They are always congruent. It's not always going to correspond. Okay? Because, where can I write this? Let's see. Even though these two triangles share that side, are those sides that is the side that they share the same part in both triangles?
No.
No. So they can share it, and it can be congruent, but it doesn't have to be the corresponding piece. So be very careful with that. Okay, be very careful with that. In this case, they do share that side, so we know that. And is it in the corresponding position?
Yeah, yes, it's corresponding.
Okay. Now, the big key is, are the corresponding pieces that we know enough to say that we have two congruent triangles? In other words, do we have enough to fit in to side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg? No. Well,
side, angle, side.
do we have all three sides?
No.
No. We have two sides and an angle.
Yeah.
Is the angle between the sides?
Yes.
No. Yeah. No.
Here's my two sides. No angle between that side.
Yeah.
So two sides, no angle there. Remember, when that angle, it is the included angle. It is the angle made up by those sides. So no, no, but we don't have two angles, so I don't even need to check that. Don't have two angles, don't need to check that. Do I know that this is a right triangle? No, so I cannot go here. So can I say that these two triangles are congruent? No. I don't have enough information. Okay, so right now, no. Not so enough info. Even though we have the pieces, they're just not in the right order. Remember, order matters.
Order matters.
Okay? How about the second?
Rethinking everything. First one works.
How about the second? What do you think?
Angles at angle.
Yeah.
Sure?
Yeah.
Positive.
102%.
These two don't. 102%.
Love for you to explain for me how you do that.
These two are congruent, they're not corresponding.
But then there's,
But they share the
both
side.
the same side, so it's angle and then side, and then I did that.
But that still doesn't say that this and this can match up. How's that happen?
I mean, turning 180 degrees.
Exactly, it's a.
Ah, so, yes, they do share that side, and yes, these two are congruent because of angle, side, angle. But it's not these two, it's not folded over. So what you have to do visually, and this is where some of you guys that have some great spatial ability are going to be able to do this. Those of you guys that you haven't used that spatial ability so much recently may struggle a little bit, but you got it. All you have to do is
Flip it around.
turn that thing.
The opposite.
Yeah, because you don't.
Turn it around. Okay? How about that guy? What is that? No way.
I wonder about this.
Okay. Side, side, and then share that side. Don't I need an angle? Don't need an angle if I have all three corresponding sides. So this one works as well. All right, last one. How about that number 4?
ESC.
SSS.
ESC. No, not enough.
No, number 4?
Wow.
Number 4 is ASA.
ESC.
They say, ladies say, ASA. Gentlemen?
ESC.
It's not, it's not.
It's not ESC. It's not.
It's not.
You don't get it.
It's not.
I have
Yeah, yes, you do. Vertical angle. What's the ESC?
Did you say something?
I don't know. It says one here again, too, it says something.
Which ones are vertical? Those two. I never did that. Yeah, these two are vertical. What do you know about all vertical angles?
They're congruent.
All vertical angles are congruent. So no, explicitly they did not give me a second pair of angles, but I know back from stuff that we've already done, if I have vertical angles, all vertical angles are going to be congruent. So now I know from using my prior knowledge, vertical angles are congruent. That's one pair of angle. That's a second pair of angle. Do I have the side that is included or the corresponding side that is not included, whichever one, in this?
Yeah.
Which one? Included. That side is
That's it.
included between my angles. So I can use ASA. Okay? All right. So we got to start thinking, right? Right, good, good, good. Some of us, it's a little more difficult than others. Uh-oh.
Oh, no.
What side?
Alright, who's got number 5?
Nothing.
Alright, ask us what?
Nothing.
Nothing. Are you kidding me?
Yes.
You sure?
Yeah.
Positive. But I can't. Can I take this and just pull it over and lay it on top so I can grow it? Because if these two match up, if I pull that on top, those two match up, they gotta be congruent.
Yeah.
Even though I can do that and the corresponding pieces, these two pieces are good and they do match, I need that third piece or I need a little bit of information. Not enough information. Okay. Yes.
So what is the textbook definition of hypotenuse? Hypotenuse?
Textbook definition of hypotenuse?
Yeah.
The hypotenuse, I need you to pay attention, the hypotenuse is this. The hypotenuse is only existent in a right triangle. The hypotenuse is always located opposite the right angle. Okay? That's it. There's your textbook definition of the hypotenuse.
So
The side of the right triangle located opposite the right angle.
So what would you call the wrong side of the triangle that's not the right triangle?
The long side. Yeah. You look
Like,
Okay, who's got number 6?
Sorry.
It's not HL.
What? It's not HL, it's a right triangle. It's gotta be HL.
What, number 7?
No.
6. You guys are all wrong.
Yes.
Right angles, gotta be HL.
No way.
No.
No way.
Yes.
You know it.
I mean,
You guys made that mistake. You don't have to answer that. But yes, if you made a mistake, yes, these are right triangles. That does not mean that you have to use HL. Okay? It could, but it doesn't have to be. What is important is the information that we have. Well, what information do we have? What information do we have?
the hypotenuse.
Do I know anything about the hypotenuse?
No, one.
No. Well, if I don't know anything about the hypotenuse, I can cross off the HL. What other? Yeah, what about it? What about it?
They're included, sir.
Included. Wait a minute, I've only got one pair of angles.
Yes,
the
so
other
only a
angle?
vertical line.
Again, we have a pair of vertical angles. And I do have the included side between the second pair of angles. So this is what?
HL.
Angle, side, angle. All right. Cross set. Say yes. Side on side?
Nothing.
Why is this not? We got two sets of congruent sides and one pair of angles. Two sets of congruent sides and one side on side.
One of them are included. One of them are included. No, they're not corresponding. The angles are not corresponding.
But wait a minute, they're congruent.
They're not included.
But it's not in the right place. Even though this is included, this one's not included, and they are both congruent. They must be congruent and in the same position. They're not in the same position, so therefore not congruent. All right. How about number 8?
That's
Side, pretty easy, right?
Yeah.
Uh-oh. Okay, step it up a notch. Now, what you're gonna do with each one of these, you gotta think a little bit. Let's see when the mark is so dark. Okay, what you have to do now is for each one of these, we are given what we want to use, but I'm not given enough information to use them. So what I've got to do is I've got to take the information that I have, look at what I want to use to prove it, and find that one piece of information that is needed to use that. Does that make sense? In other words, you're missing some information. What is missing in order to use? ASA, SAS, SAS, or ASA. So, 4 problems, find the 4 missing pieces.
Measure the amplitude. Because what's the vertical axis? And then the side is giant.
Measure angle D.
Yeah, the one in the middle is the side. Now let us find that the measure of angle DUT is equal to the measure of angle CUS.
Can you just write an additional pair of forces?
Well, since we are, that's a great question. Since we do have the vertices labeled, be specific about what piece of information you need to have. Don't just say, I need another pair of angles. If it is another pair of angles, which pair of angles? So not only do you have to be specific, you also have to be accurate.
It's parallel to the area times the base times side. The nuclear area is not it's the 2 squares that correspond to the side. Something is oh my god.
Are we ready to do number 11 just to make sure we're on the right track?
For 12, you need to know that
Oh.
the other corresponding sides of the mean that has to be.
Thank you for telling me.
Careful, don't beat them too much. Run his hair.
Wait, you said for number 11, it's supposed to be like measure angle PU.
Well, you said the measure of angle DUT must equal the measure of angle, which one?
PUS.
Does that work? Knowing that information, would we be able to use angle side angle?
Yeah.
Okay. Could I have written that another way? We could have written it in measure of angle SUC, or did I have to write equal measures? I could have written it as what? Which one?
Number 30.
Guys, give me 1 second. Go to what? Pictures for you. Oh, really?
I'll put portrait, it'll put that in.
You know what? I would love to see how you put portrait in this, but It's supposed to be equal opportunities in yearbook. When you look like this, you just want to fill out the yearbook. Okay. Any other ones we can't read? This is B. A, that's K, C, L. Not real sure what that is. Call that J. Call that D, F, L. Call that another J, K, and a E.
That's even more confusing.
I know. All right. So for number 12, if we want to use side angle side, what do you think?
Line segment W, V, as we can go to the line segment X, T.
Segment WB has to be congruent to segment XK. Let's critique it, see if it works. So we have this angle here being congruent to that angle there. How do you know those are congruent?
Because they're meeting each other, they're. Yeah.
How do you know those two angles are sharing?
Side.
No. Two angles are never congruent because they share a side.
Because they're right.
Those- What?
Because they're right.
Yes, what do you know about all right angle? How do you know? Because they both have, all right angles have a measure of 90 degrees, they all have the same angle measure, so if all angles have the same measure, they are congruent, right? So we know we have those pair of congruent angles. Where's the side that we know? Shared side, okay? So then we're looking at segment WV and segment XK.
Okay. And then also be segment XW and segment KB.
If we said these two, would I have their side angle side? Because I would have this already. Do I have the side angle side orientation? No. Because of this, we can't use those. Okay? How about number 13? Again, we want to use side angle side. So we have a side. These two are not touching, so there's no shared side.
So, segment CA has to be congruent to segment LG.
And those two segments have to be congruent in order to get side angle side. Okay? How about this last one? Angle side angle. When we get angle side angle, what do we have to have?
Two corresponding
Sides.
sides.
Are we given the two pairs of angles, or are we given a pair of angles and a pair of sides? Okay, so we need what?
Corresponding.
We need a
Side.
pair of sides. Where does that pair of sides need to be? Included or not included? Included. So where is that going to be?
Line segment D and line segment K, J.
Excellent. And I love the fact that you guys are starting to use the correct vocabulary, by the way, already. See how quick you guys learn.
I like the other version, but.
You like
Yeah.
Alright, are we good?
Yeah.
That's why you left.
All good, okay? Alright. Alright. It's all bad. Focus on that. Alright, a little bit different problem, back to the same type state. If the two triangles are congruent, if they are, how do you know? It's my best side. All right, this is bless you. This is back to the first stop. We have stated the two triangles are congruent. Do we have enough information to say in number one that those are congruent?
Yeah.
No? Yes? Maybe? Yes? You understand? Yes. Why?
Because there's Jason, there's just lines that it goes.
Not adjacent, but they what? Starts with an S. They what? By a part of the K bar, and then you see what I do what? Share. Share. Then yes, this actually is bisecting the segment. Okay, but
Also,
back to this, we share this side. Okay, so now if it's shared side, we know that's congruent to itself. We have a pair of segments that are congruent. Well, I've only got one end.
so, the is 180.
Okay, we got a straight angle.
Yeah, you,
Half of it is 90, so the other half is
like,
90. So just by telling us the one, we know the two. So do we have enough information?
we can also use HR.
We could also, can we use HR?
Because A square plus B square equals to C square.
Okay.
Right angles. So if we got two angles, two lines are equal, we can get two sides are equal, we can get the third sides are equal.
Okay. Now, yes. How many guys have used Pythagorean theorem before? What'd you say? Probably the first person that's ever said it correctly the first time. So give you that A's, B's, and C stuff. Doesn't work. Okay. So length squared plus length squared, that's equal to hypotenuse squared. But we don't even have to go that far. We could say that we had side angles side. Now, we could go a step further and say, since they are right triangles, we could say that we have this, and now if we have that, and we know it's right triangles, not only can we say side over side, hey, not only can we say it's side over side, what else can we say? When it's hypotenuse leg. Not only can we say it's side over side or hypotenuse leg, what else can we say?
Side.
Now we can also say side, side, side. Okay? So there are times where we are going to have multiple ways to say it. We don't have to take it this far to get this third side in order to have congruent triangles. We could if we had to, but we don't have to. How about here?
It's nothing, it's.
Nothing?
No, it's HL.
Oh, you're just gonna jump on that? Does this, number two, satisfy the conditions for hypotenuse test?
Yep.
First off, do we have two right triangles? Yes, we have two right triangles. Do we have the hypotenuse in both of these being congruent?
Yep.
Side opposite the right angle, side opposite the right angle. Check. Now, the question is, are the corresponding legs congruent? This is where it gets tricky. I'm going to show you a little easy way to do these. This one has the leg that goes from the right angle to the corresponding, or to the hypotenuse. Right? It's a little bit tricky because so does this one go there. Well, this one, and this is where we kind of cheat a little bit. This looks like it is the smaller one. Or if I turn it, okay, I can match it up. So yes, these do match up. Yes, these do match up. Okay, so this is hypotenuse leg. Be careful with that though, because sometimes when we assume things and we go by what it looks like, it gets us into trouble. How about this guy?
Yes.
Angle, angle, side, but it's a right angle. Can I go hypotenuse leg? Why not? I got a hypotenuse.
You have two congruent legs.
I don't have any legs. All I know is the hypotenuse, so I can't do anything. But I can do angle, angle, side.
Well, if you know that angle on the side, then you can pretty much say that it's.
Once I have it congruent, then I know all of my corresponding pieces, then I can go back. But again, that's That's like finding gold and saying, well, if I found gold here, then I'm gonna dig in that spot again. Oh, I bet I'll find gold. You know, you're doing something twice. You don't have to do it twice. Okay. All right. How about number 4? There's no shared sides here. How do you get another angle? Vertical. What do you know about those vertical angles?
They're not.
They're congruent, and not only are they congruent, they're what? The right angles. Okay, so now we have 2 right angles. So I should be able to use hypotenuse leg. Why not? You guys got something against hypotenuse leg or what?
You still have the,
Don't have enough. Even though I thread the hypotenuse, it's only angle, side. Okay? Also.
Also use like exterior angles and mobile interior angles.
For the exterior angles, for what?
The exterior angles equals to those 2 angles, and the exterior angles, 2 exterior angles are equals. So we get 3 angles equal, so we get A as.
We could do the, what do we have? Not only the exterior angles, but that we know that 2 angles in one triangle are congruent to 2 angles in another triangle. Yeah, what do you know about that third angle? They're also congruent. Okay, so we know those are congruent, then we can also do angle and side. Okay? Or we could do angle, side, angle. Okay? Good. Now, we'll challenge brain a little bit. I know, some of you, that's a difficult task. All right. You're gonna need to pay attention because now I'm gonna see what you can put together. And I am gonna be quiet. Just so you can read it, I'll make sure you read it. The first one says triangle ABC has the coordinates A with -4, 2, B -3, -3, and C -1, 0. Triangle CDE has the coordinates C -1, 0, D 4, 1, and E 1, 3. Given that information, is triangle ABC congruent to triangle CDE? Who has their computer and who has GSP loaded on their computer? Want a couple volunteers, try to do this by paper, and I want a couple volunteers to do it by GSP. Well, I tell you what, if you have GSP, I will allow you to do GSP. If you don't, see if you can do this by
Chinese is better.
Yeah.
That's what I was here, right? To schedule
No, D, C, D.
See, that's how I remember it. Sorry.
-4, right, 1, 3, and my
Yours?
And we just do that. Is it what it is?
Why is like connection lines and everything? It's what? These are it's true. One and two. Oh, wait, I should get it. Beautiful, addition to.
If you are savvy enough on your calculator, you could also do this on your calculator.
I forgot what it was.
Why don't you do that?
190. So that's more. You guys see that? It's 36. Yeah. Is it 32? No, it's 36.
It's still.
Is it English?
Right, download it from Chinese website.
Yeah. Is it English?
That's not cheating, that's just not using brain. Okay, they are.
They're not congruent.
Not
They are. They are. They are. Which I do from
Instead of using GSP, you should use it brain. Work brain. It's good looking at it for your size cube. C is minus 1 here.
exactly.
Where do we go for that? Yeah, absolutely. That's your user. Where do we go for
Is it good as far as the proportion?
You go where.
Oh, no, they are
Class advisory.
I messed one thing.
That's a full class.
Okay, so how do you see that? Why did you
They are congruent. Yes, they are. Yeah, they are.
It's measured
I'm gonna measure the distance to do it. Show us on neutral.
Oh, okay, so he's measuring it.
Yeah.
This is messed up.
So you can take that. Do we get the measure?
Seriously,
Yeah.
I miss little school. It was you that we actually use it. Actually, right. And want class 86. 6.88, 6.26. Yes, it is continuing.
Are we starting to get some results? Yes? No? Congruent, not congruent? No, it's not congruent. No, it's in always. No, it's no, yes, no. All right. Let's start with the old school method. How would I do this paper and pencil?
You find the distance between all the points.
How would I know which ones match up?
Huh?
How would I know which ones to compare?
Because just find the measure of the corresponding sides, and if all of them match, then they're congruent.
How do I find the measure for those?
There is a formula.
Really? Which one?
The D formula.
Distance formula. What is the distance formula?
Root square of x2 minus x1 square minus plus y2 minus y1 square.
Anybody know where this comes from? This is around a lot lower than Mr. Rissy. This is in coordinate form, solving for the hypotenuse. Okay, solving for the distance between 2 points. Because if I take this real quick and I put it in rough sketch, this is not going to be accurate, but if I put a rough sketch, 1, 2, 3, 4, 5, 1, 2, 3, 4, well, if I go -4 to 2, and then I go -3, -1, 2, 3, -1, 2, 3, and then I go -1, 0, and I go to C. Well, if I want to find the distance between A and B, that is a horizontal distance and a vertical distance. The distance between A and B is the hypotenuse of that triangle, which is why this is from Pythagorean theorem. So, knowing that, all I have to do is plug in the pieces that we have. Well, if we're going from A to B, what's my x2? What's x2?
-3
Okay, so -3 minus
plus 4.
-4 squared plus y sub 2,
-3 minus 2.
-3 minus 2 squared, -3 plus 4.
-1.
One squared is 1. -3 minus 2,
-5.
-5 squared.
25.
1 plus 25.
26.
How many of you guys took the square root of 26 and got some crazy decimal? How many guys just left it as square root of 26? Just leave it as square root of 26. If you're comparing numbers, much easier to look at the square root of 26 and compare that to another number. Okay? So then we go from A to B, then we go B to C. What did we get from B to C? Anybody do this by hand? What did you get?
Root square of 13.
Square root of 13, and then you found A to C.
Yep.
And
Same as BC.
same as B to C, square root of 13.
Yeah. Trinity.
Do we agree with this? Anybody? We'll just agree with it because it's Greek. Trust me, he's a shady fellow. He'll lead you the wrong way.
Isn't it B squared?
Well, if you get rid of the square root, then yes, that difference squared is equal to this difference squared. Yes, but if we're just finding that difference, we take the square root of the side. Okay, now, those of us that did it in GSP,
Yeah, I did.
did you get congruent triangle? Did you get these values? Well, we haven't even answered whether it is congruent or not, because we've only got this for one triangle. So we still have to go through, and we've got to find the distance from C to D, the distance from D to E, and the distance from C to E. So what's the distance from C to D? Square root of 26. Well, so far, so good. D to E, if we went through all this work, what do we get?
Square root of 13.
Uh-oh. And then hopefully the distance from C to E is the square root of 13, is it?
Yep.
Square root of 13. So by paper and pencil, are these two triangles congruent?
Yeah.
Yeah. By GSP, are they congruent?
Yeah.
Yes. What you have to be careful with in GSP, okay? How many guys have your GSP up in all of this on the screen right now? Let's see here. Watch, yours probably won't pick it up.
There's a meeting. But okay, that's what the teacher do. I was presenting. I'll back it up. Don't change.
Okay, what I was gonna say on the GSP while we're trying to get this straight. On the GSP, what I strongly suggest, if you are doing this, do not just go and put the point, input coordinates, okay? Otherwise, you are going to find incorrect values.
What's this?
Is it? I didn't know. It says,
What if it's 89.9%?
measure. 90.6 is not
That's
90.
still not right. That's not right.
90.6 is not 93. Okay, so when you put things into GSP, what I strongly suggest is if you are trying to figure this out using GSP, put in the coordinates. Do not use the application that you can take and place a point, because on GSP, if you place that point and it is a hair's width off of where it should be, and you calculate that length is going to make a difference here. And then when you calculate this length, because it's just a hair's off there, it's going to make a difference. And then you're going to look at those two values and say, no, they're not the same. Boom, they're not congruent. What you need to do in GSP, put the bottom. What you need to do in GSP is you need to input the coordinates and not gather windows. Right here. There you go. Okay, we need to see there's slight differences. And let me ask you this: did you use the point and pick on. See how it's slightly off right there? If I zoomed in right here, you can see how it's slightly off. It's a very good estimate. But when we use the GSP, we want to make sure that we input the points. Even though these are very close, 4.91, 4.85, all right, you might one time say, ooh, they're pretty close. They should probably be congruent. And you might be right. And then the next time, they should be really close, even if you did it by paper and pencil, but they're not congruent. And you're going to say, well, they're really close this time again. They got to be congruent, and they're not supposed to be. Okay? So if you are using GSP, if you are using graph paper, if you are using any of this stuff, make sure that you plot these accurately and precisely. Okay? Then and only then can you use it to get something that is going to prove or disprove something. This, we don't have to worry about graphing. I just use my coordinates. Okay? But something like this, which is a great tool, but make sure you use it appropriately. Same thing with your calculator. Your calculator can do this as well. Okay? You can input your values into your calculator, find the distance between the 2 points, and use your calculator with this on the graph part. Okay? It also, you can also do all of this right in your calculator as well. You don't have to worry about calculating any of these. All right? All right, awesome. You can unplug that. Now, knowing that, thank you. Let's try it again.
Mr.
Yes.
Did you get it? Should I go to the bathroom?
Not in here, next semester.
Okay, back into it. Did we get our test back?
No, I haven't finished grading.
Nothing to say.
Okay. Different points. Now, is triangle ABC congruent to triangle DEF? You can use the GSP appropriately, or you can use the paper and pencil, or you can graph.
It should be not congruent because last one was congruent.
Oh, you're gonna fall into that trap, right? Well, then in that case, I would say, well, they're gonna think that the first one was congruent, so the second one should be not congruent. But if I know that you're gonna automatically assume that the second one is not congruent, I'll go ahead and make the first one congruent.
Okay,
But then if you think of that, then you say, well, if it thinks that I'm gonna do it that way, then maybe it is gonna be not congruent. It's just an estimate. Yeah. So in other words, go ahead and do the math.
She's a big boy. Oh, dude, you brought me around. It's like that joke there. You went by that even though you didn't know you were. This is fake. The negative sign is inside of the parentheses. It's outside and just.
This is not a whole.
Math.
It's dark on the class. This is not a classroom. It's a Chromebook. I Chromebook. Yeah, wait. Oh, you know, let's try. No, it's just yeah. Let's see what goes back. If I do it like this, so we just undertake it. Or you should just. It's not. It is. It is. The first one, 1 root curve, you know, second root curve, 2 root curve. The third one is root curve.
Yes.
Oh, I meant.
Are they on?
Yeah, there's.
So, did we find an answer to this solution?
Yeah.
Are they congruent?
Yes.
I did say a little tricky. What did you use to prove these things?
Exactly right.
That thing.
GSP.
So which one of the 5 ways did we do? No, which one of the 5 ways? We have 5 ways to prove 2 triangles are congruent. By doing this, yes, by either doing what you did in the GSP or this, most of you, I think maybe one of us tried to calculate some of the area and some of the angles, which you can do in the GSP, if you plot the points correctly. But if you did it by hand, we did side, side, side. Now, what you could do with the GSP is take those, okay? What I can do is I can give you values or coordinates of points, and I can say, find the measures of the angles, okay? Or I can give a little twist to it. I say, okay, outside of using side, 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 give me the information that you would have in this diagram or in this information that proves that you have or do not have congruent triangles. That way you cannot, you would have to do something else in the distance formula 6 times. Okay? We would have to find the measure of one of those angles. Okay? So those things are valuable. Alright? Now, that's just about out of time. You guys have advisory. What I will do is I will put some questions on Google Classroom, and that's where your homework will be. Post it up.